Hi everyone, Ravi this side. Welcome to EnggAdda. Today in this video, we are going to discuss about virtual thread, what it is, what are its advantage, and how it is different from the normal threads. Everything we are going to discuss in this video. And then we'll also create a scenario where we'll try to use the virtual thread as well as the normal thread for some task, and then see the performance of virtual thread and the normal thread for that particular task. So this is the today's video agenda. Let's get started, and I will go to the next slide to discuss more about the virtual thread. So virtual threads are lightweight threads introduced in Java via Project Loom. So they are introduced in Java with the help of Project Loom of the Java, and it was introduced in Java 19. So this is the basic of it. It is a lightweight thread. It was introduced in the Java via Project Loom. The first thing is these virtual threads are not tied to the OS threads. How the normal threads are tied. So the normal threads are created on the OS level. They use the OS resources, but the virtual threads are not tied to the OS threads. These are managed by JVM, allowing for efficient resource uses. Okay, so they are managed by these virtual threads are managed by JVM, and they are very efficient at the resource uses. Virtual threads are ideal for handling high concurrency tasks. What are the high concurrency tasks? So let's say you have developed a application, and you have developed couple of APIs. Okay, and you have so many of users. Let's say Netflix has millions of users, and when they, or let's say Hotstar, when they stream the this crickets or other sports, you can see at the time we have 5 or 6 crores people are viewing those things, right? So that are the high concurrency tasks. So these are handled by the virtual threads in a very efficient manner. Okay, so this is the uses of virtual thread, and this is what virtual thread is. It is a lightweight thread introduced in Java via Project Loom. It is not tied to the OS threads. It is managed by the JVM, and it is ideal for the high concurrency task. So this is the basic of Java virtual thread. Now I will go to the next slide to discuss why we use virtual thread. So for the high scalability, one should use the virtual thread. It handles thousands of concurrent tasks efficiently. If you want to manage the memory, then the virtual thread is lightweight. It uses significantly less memory than normal threads, which is in the case of virtual thread it is 2 KB per thread, and in the normal thread it is 1 MB, which is very much less, right? Virtual thread simplifies the codes. Write blocking style code for asynchronous task. So if you have the asynchronous task, it will manage it very efficiently. The virtual threads are optimized for IO bound operations, perfect for database calls and REST APIs. So these are the benefit of using virtual threads. So this is the scenario, and this is why one should use the virtual thread. Now there are so many things that virtual threads do, but these are the main things that we can focus on. Now go to the next slide. Here I have listed down couple of difference between the normal and the virtual threads. Okay, so the normal threads are basically mapped to the OS threads. They are heavyweight, high memory uses, and limited scalability due to the OS thread limit. So every OS has a thread limit, and the normal thread is mapped to the OS threads. That is why it has a limited scalability. It is heavyweight, and its memory uses is 1 MB per thread, and it is mapped to the OS threads. Okay, coming to the virtual thread, it is managed by JVM, not tied to the OS threads. It is lightweight, and it is highly scalable. Okay, so these are the difference between the normal thread and the virtual thread. Now I will go to the next slide, and here are some additional points I have noted down. Virtual thread simplifies debugging due to the stack trace for every thread. So in the virtual thread, we have the stack trace of every thread, and it helps us in debugging the thread life cycle, you can say, or how the thread is performing, what are the things, everything we can debug. Better resource utilization under high concurrency scenarios. So virtual threads provides better resource utilization under the high concurrency scenario. It is fully compatible with existing Java libraries and frameworks. Okay, and particularly useful in microservices, APIs, and event-driven architectures. So in these days, mostly the Spring Boot and the Java are used to develop the microservices, APIs, and the event-driven architectures, right? So the virtual thread is very much compatible with them. Now going to the next slide. Here what we are going to do is I will try to create a simple application. Either we can create a Spring Boot application, but that is of no use. But we can do is we can create a simple Java application, and then there I will try to create uh, a class, and we'll try to see how the normal thread and the virtual thread performs for a certain scenario. So we'll try to have a task, let's say, which has 10,000 concurrent requests, and then we'll see how the normal threads responds to that and how virtual threads respond to that. We'll also log the time and execution times and everything. We'll try to log for both of the threads, and then we'll try to compare. So this is what we are going to do now. I will come out of this slide and create a application, and there we'll try to write down the code. So let me open the IntelliJ here. Just wait for few seconds. It will take few seconds of your time to open it up and then load. Then we'll create one class. So it is taking few seconds of your time. I have restarted my system, that is why it is taking some time. No issue. I think it is opened up here, and let's say go to the file, and I will create one project. Let's say virtual thread demo. Okay, Maven. Anything is fine. Either you can create the Spring Boot application or any application is fine for you. So just create it out, because we are not going to use the this Tomcat and all those things. We are not going to develop our REST API. What we are going to do is simply we'll create one class, and inside main method we'll try to see this video. Usually we'll try to create a Spring Boot application that I'm creating it out. Let me close this one where I have did the practice. So let me create one class here. Let's say compare dot high concurrency task. Okay, let me refactor it out. That is not allowing me to refactor. I think the application is still loading. Okay, now it will do. Refactor. We'll wait for a few seconds. Just wait. It is resolving the dependencies, or you can see, right, we have added this Spring Web. That is why it is downloading all the starter dependency, and then it will take few seconds. Don't worry. So our application will be up in few seconds. And yeah, let me do a refactor. Still not getting these things. No issue. We'll try to delete it out and then create new. So I have created this package, and then we'll create a Java class, high concurrency task. Okay. Now this is a class I have created. I will create a main method here, and inside this we'll try to do the comparison of virtual thread and the normal thread. So what I'm going to do is I'm going to create a task. Okay. So I'm going to create a variable called task, and its count, let's say, would be 10,000. or you can take, let's say, 1 lakh, anything is fine. Okay, as of now we are just taking 10,000. Now what I'm going to do is I'm going to create a like virtual thread execute, sorry, normal thread executor, and we'll try to perform this task, 10,000 tasks with the normal thread, and then see its performance. So first of all, let me try to log something. Let's say testing the normal thread for high concurrency task. Okay, now what I'm going to do is I'm going to create a start and the end variable, which will try to capture the start of the thread, like start, and then like this variable will try to capture the time of the start of the thread, and then the other variable try to capture the end of the thread, how many times or how much time it will take to complete this 10,000 tasks. So for that only we are going to create two variables. One is the start and another will be end, and we'll try to see the time taken by the normal thread to complete this 10,000 tasks. Okay. Now for that, let's say a long start, and now we'll try to complete this task. Let's say int I equal to 0. This task, inside this task we are going to use the normal thread. Okay, so for that let me create the normal thread here. Where normal executor dot new thread per task I'm going to use. So just executor dot, there are so many options available under the executor to create the threads. Either you can use new single thread executor, or there are so many options, right? You can see new thread per task executor, and you can also create your own pool, thread pool, and assign the task to complete by using that thread pool. Okay, so everything is available here, but I'm going to use that new thread per task execution. Okay, so just import this executor, and you can use per new thread per task executor. Okay, here what you have to do is you have to provide the platform thread. Okay, so platform thread is the normal thread dot of platform dot factory. Okay, yeah, good. Now why we are getting this, set language level to 19. Okay, so Java 19 should be there. So I'm going to check, go to the setting, not here, project structure. Here you can see that we are using Java SDK 21. So make sure you are using more like the Java version, either it should be 19 or above above than that. Okay, and here if you'll go to the pom.xml, let me see. Okay, inside this we are using Java 19. Okay, above will go, here it is Java 70. Let me convert it to the Java 21. Just rerun this maven so that it can load it out. But as of now, like, it won't take the Java version from here, because this is the web application and we are not going to use that one. We are just going to use this main method to call this out. For that, it will take the things from here, from the JDK that you have selected. So we have the Java 21 selected in the JDK, but for the safe purpose, I have just changed that Java version from 17 to 21 in the pom.xml. It will take from here, but also change it there itself. So we are good. What we did is we have created one normal thread task executor, which will try to complete this task of 10,000 count with the help of new thread per task. Okay, and here we are creating the platform thread, which is a normal thread. So we are good now. Now what we are going to do is we are going to use this normal thread executor to complete this task, and we'll see how we can see introduce some of the scenarios. Okay, so let's say if you are going to complete the IO operations, then each IO operation will take some time to hold, right? So for that only we are going to introduce some delay here. So how we'll do that, we'll show you. So here let's say normal executor dot, we are just going to simulate the scenario here, submit, and we are going to call the, let's say, IO operation or any other operation. Let's say you are going to call the APIs. So to return, like the API will take some time to return the response, right? So for that only we are going to simulate that, and we are going to introduce some artificial sleep, or you can say delay. So for that only we are going to use this simulate task method. Simulate task, and we are good. Now I'll create this method here, and inside this we'll try to introduce the delay. Thread dot sleep, let's say 200 millisecond, and surround this with the try and catch. Okay, what it is, let's say it's void, so we are good. Now we are calling this. Okay, so simulate task is the task that will take let's say per task it will take 200 millisecond to complete out. Okay, and this is the task that we need to complete, and like simulate task, there are 10,000 of simulate tasks that we need to complete, and we are using new thread per task, and we are using the normal thread to complete this task. Okay, so this is the whole flow. Let me again remind you, we have created, let's say, 10,000 tasks. We have created a normal executor. With the help of a platform thread, we are creating the normal thread, and then we are using this normal executor to complete this 10,000 tasks. Okay, and each task will take 200 milliseconds to complete out. Okay, it can be IO operation, it can be API call, anything would be there. So this is how we are creating the scenario. Okay, now I'm going to create a variable called end, and we'll try to capture the time taken to complete the task. Now I'm going to print something, let's say execution time, total execution time taken with the normal thread and all those things. So let's say total execution time taken by normal executor or normal thread. Now we'll try to separate the start from the end, and it is in millisecond, right? So we are good. Now let me run this main method and then see what we are getting. You can see it's running, and it will open up the console for us. You can see this. Let me expand this out so that you can get testing normal thread for high concurrency task, and total time taken by the normal thread is this, which is 6026 millisecond. Okay, now let me move this one. It will look good now. So to complete the 10,000 task, it take 6026 millisecond. Now it is taking 1491 millisecond. Again, let me try to run this and then see how much time it take. It is taking around 15,080 millisecond. Okay, so this is the time taken by the normal thread. Now what we are going to do is we are going to see how the virtual thread is behaving for this task. So here we are only taking 10,000, right? It can be a million of request. So it can, the task count could be million, right? But we are just testing a 10,000 request count. Now let me try to create the scenario for the virtual thread. So first of all, I'm just going to print out something like testing the virtual thread. Testing the virtual thread for high concurrency task. Okay, and just remove this thing. Let me change the. Okay, so here we'll try to write the logic for the virtual thread. So this all the things would be same. Now what I'm going to do is I'm going to create the start and the end variable. So let's say long v start, and now what we have to do is we have to create the virtual thread executor here. Okay, and what we are going to do, we are going to use the executors here. Dot, you can see new virtual thread per task executor. That is what we are going to do, and here we are going to use the virtual thread. Okay, so thread dot of virtual dot factory. Okay, so it will create the virtual thread for you, and this is what we'll use to complete the task. Okay, so let me remove this. We are not going to use this. We are going to use the new thread per task only. Okay, new thread per task executor, and inside that we are creating the virtual thread to complete the task. Okay, how we are, like, we are using new thread per task. A new thread will be created per task, and the thread that is created is the normal thread, and here the new thread will be created per task, and the thread that it is created is virtual thread. Okay, now we are good. The same thing we have to do here. So let me copy this out. Let me copy the whole thing. Just paste it here. Now you can see we are going to complete this task with the help of virtual thread, and we are good. Now let's say v int, and total time taken would be v int minus v start. Okay, we are good, and here you can see the same thing we are doing. We are simulating the task, and I think let's look good. So total time taken by the virtual thread will be this. Okay, so we are good. Let me try to run this and then see the difference. So it will take few seconds. You can see that testing the normal thread, it takes 1726 millisecond, while the virtual thread takes only 546 millisecond. It is the case when we are only testing the 10,000 request, but when it will go to, let's say, 1 lakh or 10 lakh, then let's see the response, how much time the normal thread takes and how much time the virtual thread takes. You will see the difference because the virtual thread is suitable for high concurrency task. Okay, so just wait for few seconds. It will show you how much time it will take for the normal thread to complete the high concurrency task and how much time it will take for the virtual thread to complete the high concurrency task. So we have drastically increased the numbers, so it will take few seconds of your time, so be there. Yeah, so it took me around 10 12 minutes to complete the whole task. You can see that it took around 8 lakhs 10,362 milliseconds for the normal thread to complete the task, and it took only, you can see that, right? The difference is so much huge. It took only 1569 milliseconds for the virtual thread to complete the task. So this is the difference between the normal and the virtual thread. This is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.